Good evening to one and all present here. We'll start this session in a couple of minutes. Welcome, sir.
Welcome, Saravanan. Good afternoon.
Good afternoon, ma'am.
Good afternoon, everybody.
Hello, Lavanya, can you hear me?
Yes, sir. I can hear you now.
Okay, looks like I have a problem with my laptop. I'm not able to.
Oh,
The audio is not working, video is working.
okay.
So I joined by phone as well, just in case.
Okay.
Let me see if I can share the screen, right, in my laptop and then see if that works.
Yeah, we can share yours.
I'll try and share my screen and see whether that works.
Okay.
Okay, you are sharing, so it's not allowing me to share. If you can give me access.
Yeah, we can.
Okay.
So now we can stop sharing the screen and allow Mr. Saravanan to share.
Thank you. Okay, tell me if you can see my screen.
Yes, it's
Great.
visible, sir.
Okay.
So we should start the session, sir. We should start with the former welcome.
Sure.
There are no secrets to success. It is the result of preparation, hard work, and learning from failure. A warm good evening to one and all present here. I, on behalf of the Department of Computer Science, University of Madras, MHRD, RUSA 2.0 Biomaterials team, welcome you all to the International Congress on Industry Perspectives of Data Analytics. We all had very useful, interactive, and informative sessions for the past 2 days. Today's topic is integrating robotics process automation with data analytics. I request Dr. B. Lavanya ma'am, Principal Investigator, Biomaterials Team 2, to say a few words about our resource person.
Yeah, good afternoon to one and all present here. And thank you, Mr. Saravanan, for accepting our invitation and joining with us and for your knowledge sharing session. Just a few words on our resource person. Mr. Saravanan is a freelance digital strategy consultant, Chennai. He has completed MCA from University of Madras, a proud alumni of our department. He's passionate about information technology and the positive difference it brings to the mankind. He believes that true artificial intelligence is around the corner and we are still not prepared to harness it. He has successfully delivered a project using distributed agile delivery, spanning across 3 countries such as US, Canada, and India. He has led and successfully delivered one of the most complex and multi-year transformation program for a Midwest regional-based bank. He successfully delivered 5-year managed services and extended for another 5 years. He proposed and won a managed service deal across all development and testing combined for 5 years. He has won a large global delivery center deal and scaled up from 0 to 300 associates in 6 months. Some of his other achievements are complex and largest facets migration for a California-based regional payer organization, facets upgrade, EDI rewrites, ICD-10 compliance, and implementation of employer portal rebuild. He has experience as director at Cognizant Technology Solutions, headed projects in healthcare intelligent process automation. He has also worked as a freelance at IPA, RPA consultant. Some of his honors, awards are Vendor Partner of the Year 2008, Vendor Partner of the Year 2010, Cognizant Project of the Year 2009, and in 2011, and Cognizant Account of the Year 2011. So your achievements are, the list is going on. We are very proud to have you here as a resource person for this session. Thank you for accepting, and now the floor is yours, sir.
Thank you, Lavanya, for your kind words, and thank you for having me. And welcome, everybody. I hope you guys all can hear me clearly.
Yes, sir, it's clear.
All right. I can't see now with the screen sharing how many participants are there. Hopefully, all of them are there, and I can start.
Yes, sir, you please.
All right. So I don't know how Q&A is going to work. I know I have put in the end of the session, but anybody has it, please in between as well. You can put a drop in the chat line, and maybe Lavanya, if you can help me with that, that'll be awesome.
Yeah, we'll do it, sir. No issues.
Great. Thank you very much. So that helps quite a lot. I know you guys already had a few sessions, and a few of the speakers talked about both data analytics, business intelligence, and machine learning. So that are really deep, subjects on machine learning and how business intelligence comes into play. So what I'm planning to cover today is how data analytics permeates everything, right? And it also needs to work with the ongoing or upcoming methodology or use tool called RPA. Right, RPA is something which has been on the fire for the recent 6-7 years. It has been there before, but recent years is where it has actually redefined itself. Before, what was there was very crude, and what is now is more refined and is part of organizations. So that is why I want to talk about that and how data analytics and RPA works hand in hand, and how it will be useful for the business, right? Before diving into the presentation, the structure of the presentation will be a brief introduction on RPA and data analytics and data science, versus how RPA works and how they can both work together to benefit business. So this is the structure which you're going to cover today. So without further ado, I'll move on to the next slide. So just to give a explanation about what is RPA, right? Now this is what you see in your typical Wikipedia. So I've also given the source, so people can get to know that. You can go and see this. This is what is there. But robotic process automation is nothing but automating existing business process which is being done by humans. You all will wonder what is this means. Like we are already automating using IT systems. A typical organization has quite a lot of its processing is automated, right? In today's world, even then, there are large portions of transaction being processed by humans or manual, operation. That's where your BPO industry comes in play. That's where the people are working on those transactions in India. Those you can, if you know the industry, it's a pretty large industry. But that being said, why is that? Why they have not automated that part of process? There are various reasons to that as well. One, there is ROI based. And what I mean by ROI is return on investment. The cost involving in automating those processes may be higher, or they are complex and changing, maybe sometimes day to day, sometimes month to month, sometimes based on seasonal. Because there are laws and compliance issues which comes in from the government and the local government and state your central government and everything else, which prohibits business from investing in keep changing some of those processes all the time, right? That's the reason they made a decision to siphon off some part of the processing which would be changing something like this, or which is cost prohibitive to be in the longer run than you use it in the manual form. Yeah, is there a question? Okay, so that is where your manual processing of the BPO world happens, and what's happening is RPA comes into play in automating that manual process. So previously there were GUI-based testing tools were there, right? They can do the similar thing, but they don't have intelligence or sophistication of what RPA is brought in. what RPA brought in is ability to store data, share data across multiple systems, can be across multiple platforms. So those were not necessarily there in your GUI-based testing tools, right? Those were typically GUI-based, but then these added more, technology-based improvements so that it is easier for, IT workers to go ahead and automate the manual process using these RPA tools, right? So these are called robots or bots, digital workers, virtual workers, all kind of nomenclature which is used today. The best part is these RPA also has been reinventing itself. When it started as it was straight play mimicking human action, then they were also integrating ML to that, right? ML is what you guys over here heard yesterday, right? Artificial intelligence. Okay, but before I'm getting to that, so I want to summarize a little bit on RPA. RPA is also, not only just mimics human action, it executes a business process. It allows the business to scale. Scalability is a bigger advantage of RPA. You look at a BPO. BPO has, let's say, 1,000 employees which they're working on a particular process, right? There's a seasonality which comes in. For example, if it is healthcare, they do sign up towards the end of each year, right, on new customers. Then there's a higher application incoming happens. That time they have to increase the number of people working at least 25% to 50% at times. So that scalability is far easier in RPA world, right? They mimic that far easily because they just need to have additional workstation, virtual worker added to that. And obviously, compared to manual work, it has higher speed and productivity, and thus gives you cost savings. And manual work obviously will have at times, some manual error, but being automated, it reduces that, and then that improves the compliance and reduces risk. So those are advantages of having RPA. But what other thing what RPA also does, right, which I'm talking about right now, 1,000 workers are doing, which was all manual before. Now think about 1,000 bots sitting there doing the same transaction. So that's a IT layer, which is right now mimicking what human actions would have taken with those variations. The difference is seasonal variations can be introduced here with maybe minimal, effort. That's why IT systems are, though not been automating these processes, RPA has done that, right? So those actions and changes which were there, there's a process map which is available, which was not available before. That is only by human hand it was there. They could see it, they know what is happening, but not to a IT layer before. So keep it in mind. Subsequently, when you talk about other things, I'll also explain why I stress upon this point, right? We'll move on to the next slide here. This is where I want to talk about it. RPA become, robotic process automation, also started calling intelligent process automation. Reason, and there's other name for that as well, hyper automation is what Wikipedia calls it. This is the why they're calling it hyper automation or intelligent process automation is your dry and cut plain vanilla robotic process automation started integrating artificial intelligence or machine learning and process mining. I know you already would have heard from other speakers about machine learning. Just to give a highlight, right, how that works hand in hand is that's what machine learning also does in this case. For an example, for a use cases, it also automates a particular process. For example, you have a physical document comes in, which is paper document. Okay, the paper document has to be digitized before it can be automated in any IT organization. So that by itself, because its input is in paper form, that is used only by humans before. Now you have OCRs. OCR also is accurate only at a level where if it is printed letters. If it has skewness, other things, it will also have difficulty in accurately capturing the data which is there in the form. Not all forms come printed either. So there are a lot of handwritten characters are there. So that need to be also captured for the data. So here OCR will come into picture. OCR is there to read what is the physical form and convert it to digital. Then your machine learning layer will come in picture. Machine learning layer will actually look at that data and try to ascertain it's like, is it a correctly captured or not, and the algorithm will come into play to correct the data. So now you see how your plain vanilla robotic process automation, which is just mimicking human keystroke, become more intelligent by including OCR and machine learning. I just given one example of that, right? There are multi usage like this which require machine learning or artificial intelligence situation, which basically require a human intervention before. So I don't know how much what was covered in yesterday's session, but typically even machine learning doesn't mean that it gives you 100% accuracy. There is always accuracy tolerance which is there, which that means your accuracy level is lower. In a very good case you can get 94-95%. That being said, I don't think you get 94-95% in most cases. Predominantly, if you get 75 plus 80, they feel very good about it. What does it mean? That means 80% when it gets accuracy. That's also parameter which will tell you the accuracy level of how what fault it's getting, whichever is false positive or false, it'll push it to a human queue, and humans will take a look at it to sorry, I was getting a call, guys. Right. So whatever the data gets reviewed by humans, and again get back, push back the queue to come to a normal automation queue. Okay. So that's why RPA, what it used to be traditionally, become IPA, intelligent automation or hyper automation. Now I'll move on to the next slide, which we'll talk about data analytics. I think you guys already would have talked about this in detail in other things. Just to rekindle or to bring to attention, data analytics is always talked about, and there's a confusion on data analytics versus data science. Just want to set a foundation there so that we can move past this question of data science versus data analytics. To put all questions to bed, data science is basically a large umbrella, right? Everything which is related to data, what it has it, data comes under data science, right? Data analytics is obviously a branch of data science, right? And you have multiple disciplines there. As you said, machine learning is also one of the data science stream only. Okay, both of these work with data. Obviously, data is biggest oil. It used to be called digital currency before, but with cryptocurrency coming into play, that nomenclature is put to bed, right? It is not used anymore. So, but data is still very, very valuable. Data is valuable in so many ways. I guess you guys would have seen it in your everyday life, like how all the data which you use is being captured in some form or other, and they're used and shared, right? Even when you use your browsers and when you use your phone to use anything which is can be captured by the applications which is within that, right? So what is data analytics per se does? It has very specific focus on questions, right, which can be answered by analyzing the data which is there. So basically, it uses statistical models. Okay. So just to give a brief about how it is different, you can see data science use so many different methodologies, or data mining, data inference, predictive modeling, machine learning, algorithm development. All of these are data science, right? Because it has different streams. But data analytics specifically uses statistics, mathematics, and statistical analysis. Your pure play statistics is what statistical model is, whereas there comes to data and analytics. And that again, large data sets are used for data science. Specific, questions are answered in data analytics, which is basically when you have a particular problem to be solved. That specific problem is what you want to, figure out in data analytics. As all of this being said, as you can see, what I'm trying to come to is data is extremely important, right? Why data is important? Data is the fundamental, a unit of item which helps business to make a lot of decisions, right? For example, a business, when it runs, it needs to know how it is performing on a day-to-day basis, and it needs to figure out how it can grow, how it can thrive against its competitors. So what they need to do, obviously they need to understand, is their product or their services working well or not? So how they will get that, right? Every one of these underlying data which is being used to figure out what happens. So one is, look at, you have a customer base, right? Am I retaining my customer? Take example like Netflix. Netflix, its stock price can go down on a quarter-to-quarter basis if it doesn't show an increase in its customer numbers. So what does it mean? It needs to publish what is the number of customer who has been staying on Netflix and how many new additions is added. So that's a basic fundamental data, right, which tells you how many people are there. But then there are people who are leaving Netflix. Netflix has to figure out, hey, who left, why they left, how I can retain them, right? They need to understand the rationale behind why all these people who are there as our customer are leaving. So they're important question for them to figure out how to retain the customer. So what, how they can do it. This is where your underlying data comes in. They need to figure out, when the customer is staying on, why they're staying on. When they're leaving, what are the reasons they're leaving? So they can look at this data, and then behind the scene, they'll look at what we can do to make sure that customer is sticky, right? It could be because they see some shows in Netflix which are making them stay on Netflix for a longer time, right? For a show like Heist, or anything else, a newer show, or give them freebies, or make it available for them to see in mobile, right? Any number of methods they can introduce as a strategy to make sure that customers are retained. Again, coming back, how they retain, they will again look at the data underlying to that, right? And the other part is improving customer service, obviously, right? They need to feel good. It's both correlated in some sale, right? Your customer retention and customer service. Customer service is better, and obviously customer retention is higher. So this again is underpinning point is data, right? Obviously, the other part is your predicting sale trend. But these are some examples what I'm talking about here. The multitude of problems, a multitude of a plethora of areas which are monitored, tracked, or even strategies formed on data which is available underlying, right? So as you can understand, data, that's why this was called a digital currency earlier on, because data is fundamental. in so many ways, right? It has, it helps in so many ways for organization to do things which they do and for them to thrive. Okay. So now I'll come to the crux of why we have this session, right? How we can leverage RPA for data analytics, or how RPA and data analytics can work together. Before going there, I would like to, pinpoint one main area. That is, all said and done, data is very important for every day-to-day business and for future business, right? But then, what is the problem? One is earlier, the size of data to be handled was limited, didn't have the computing power. Now that power is there, and with that as well, we have other problems. What is the problem? Just having data in any form is not helpful, because your tools and models, it require data in a particular format. That's number one. Number two, data quality. Data has to be correct. Why? It's because your data sanctity need to be there for it to work. Are there any statistics major or statistics student in this participant? Is there anyone here in this audience who has worked on statistics? Yes, no? Hello? I guess people are muted.
I don't think the statisticians are registered here, sir.
Okay, I know. I'm just asking anybody if it's interested or have worked on statistics before. They could have done that as well. But anyway, just wanted to check. The reason why I'm coming back is, see, statistics plays a big role in data analytics as well. That's the reason I asked that. Why? Primary basis for statistics, right, to work is to identify a right sample set which is representative of the pool they're looking at, right? Whether you call data pool or whichever it is, right? So they need to identify the right sampling, which is basically represent the entire population which they're trying to analyze for whatever problem it is. If it's a problem specific, it is how it will be used. Did you guys talk about golden data in yesterday's session on the machine learning? Did you guys talk about how it has been set up and those kind of things? Lavanya or anybody?
Yes, sir.
In yesterday's session on ML, did the speaker talk about golden data or how the data is being set up for ML?
No, sir. No, sir. No,
Not
sir.
specifically
No, sir.
golden data.
Okay. So even for machine learning or statistics modeling to work, right? It need to have the sampling data. So those statistics call it sample data. Machine learning, they call it golden data set. The reason is a model need to be trained. Both in statistics, the model need to be tested. Machine learning model needs to be trained because it need to work, right? For that, they need to identify the right representing data. Otherwise, your model gets skewed of how it is predicting. In machine learning, it can get skewed because bad representation can teach you differently. For example, let's say, sorry? Yeah? Go ahead.
So there's some disturbance or not?
Okay.
Yeah.
I thought that was a question. No problem. So what I was trying to get at is is how important is the data sanctity. The quality of data is very important for any of these models to function, right? So there has to be a data. Typically, what happens is any foundation, when they talked about, maybe Shivkumar talked about yesterday on the foundation of data analytics, they would have talked about data cleansing, data classification, right? Even the quality of data which is required for it to function well, right? The model need to perform. I will highlight why it is briefly before moving forward, right? Take a ML algorithm, ML model. If a ML model need to work, which is similar to a statistical model as well, it need to have the right data for it to be training the ML model. Okay, which is nothing but in statistical world, like how you are testing your statistical model. Okay, that's why you pick a sample to test it. Right? I'm just correlating between your data statistics versus in ML. Okay, so in both these cases, a representative data which is being chosen, which represents the entire pool which you want to feed it through this model. Okay, so what does mean representative? It means all permutation combination as much as possible, so that the model or the algorithm understands or behaves correctly, so that the accuracy level of what it gives you is higher, right? And your error is lower. That's a fundamental premise in a simplified format. So what does it mean? It means when you're building any algorithm or any statistical model or your machine learning algorithm, it had to be trained with a good represented data. Okay, so that's you call it a golden data, because that is what finally it will be. Before that, you select a lot of data to test these models. Okay, the models get tested with these data to see what kind of result comes in. Obviously, they will go through that to see whether the accuracy part of it, and to fine tune the parameters, or even to fine tune the model itself. Okay, we would have talked about regression and classification, other models as well, but that's high level, right? But within that, there are so many other type of models there in ML. Similarly, so many different algorithms there in data analytics as well, in statistical modeling. But the premise in both of these are you need to have good set of data to work. Now, that aside, so if you have good data, then you can make good prediction. Okay, now I'll come to the earlier point I talked about when I talked about RPA, that earlier there are 1,000 people who are used to work manually, but now there are 1,000 bots or virtual workers using the same thing. So what does it give us? It gives you an extremely good platform to capture data, because you already are virtually clicking and doing all these things, but then it is entering those data, and it's also correcting some of those things which comes in the process stream. So you need to have to collect data which is required for your data analytics, or even for any ML model. It can be done through your RPA layer, in addition to what it is already doing. For example, you have RPA tools like UiPath and Automation Anywhere. I know UiPath has already created its own RPA analytics. Okay, that's a tool which will help you to collect data. So what does it do? It collects relevant data in the format which is required for the model. That can be programmed within the RPA layer. So it helps you eliminate a part of data cleansing or data classification, because you can input that detail into the RPA layer. So that big headache of correcting data stops there. Why I'm stressing that point is, in any ML or data statistics or analytical program, the biggest, most time-consuming data job is data cleaning, to make sure that you have the right amount of data, because running a model takes only so much time. Creating a model, identifying a model, it is fairly, I will say, less time, though, yeah, there's a complexity involved. People need to look at what is applicable to figure out the right model to bring into play. But selecting the right data is cumbersome. You spend a lot of time to figure out whether I get the right representative data or not. And that's how you are able to golden data set. To get that golden data set, it takes a humongous amount of time to get there. So that is why before that you all have all the data qualification, data cleaning, and then classification happens before, right? But with RPA, some of those becomes lesser because it can get programmatically done so that you can collect that data for a representative data. Okay. So now with this, it will help in identifying areas of performance, of operating expense, customer loyalty, to name a few. All right. So as I was stressing for the past 5 to 10 minutes on importance of data aggregation is a very important role which RP can do because it has a very easier way to collect that data as it's mimicking the process. It also can do one more thing, right? There is process mapping, which was not there, process mining, which was not there before because it was been manually done and measured somewhere, which is there with the RPA, which is is far easier to get the process mapping. I don't know how many of you know about Six Sigma process, but then those are very important for your process map is important for Six Sigma as well, to understand where the bottlenecks are, how I can improve performance, how I can reduce my overall time to perform a transaction, and how I can look at improving my customer experience, everything else. Okay, so that way RPA is also one of the primary inputs to data statistics and analytics. Okay, so there are different data analytics tools that can directly look at the data generated by RPA and then figure out how to subsequently make use of it. I know I'm not going to walk through the bullets, rather I want to emphasize a point which are there, which again, how important data is and how it can be RPA and data analytics together helps to make it happen, right? Now, before I move on to a use case, are there any questions here at this point? So they can address them before I move on to a use case and talk about how it is. I really need you guys to participate in asking questions. Otherwise, whether am I talking in air, something is above your head, I don't know. Because some of those use cases subsequently we'll talk about is very domain specific. If I don't understand domain, then very difficult to understand that. So I may not deep dive into it if it is difficult for you to understand that.
Sir, is there any relation between the efficiency and the data analytics? Because
efficiency of
in the manufacturing, they are for finding the they are recording the time and the downloading time, everything. Is it related to the data analytics, sir?
Okay, so let's look at manufacturing, right? You're talking about runtime, downtime, work queue, right? All those things are how am I using, right? What happens? How do you understand if something now efficiency is working or not working? So that's a question which is there. I want to improve the efficiency of my workforce or my factory. So how do I do it? Coming to RPA, why I draw a parallel to RPA is RPA is similar to a factory, right? Have 1,000 bots or 2,000 bot which is running, is similar to a 2,000 worker which is there, right? So same which will come into how I improve here. So when it comes to a factory, when I have
Sir, please.
Yeah.
That I understand.
Hmm.
For improving the system performance, we are finding the time load and workload, everything we are storing
Right.
and we are analyzing everything. But
Hmm.
is it related to the data analytics of the problem?
Exactly.
Oh,
That's where my point is. How do you identify to improve efficiency? So what is that efficiency question comes into play? Underlying theme is, look, I have, today, for example, take in RPA itself, right? I, 1,000 bots are running, but my efficiency means like, I process, let's say in 1 hour, 2,000
no, no,
transactions.
Patacha.
Let me complete it. Okay.
Okay, sir.
That's, if I need to improve the efficiency, that means I want to improve the number of transactions processed by the tool, right? Or look at your manufacturing world. I want to increase the number of parts being produced by a particular stream to this. So I need to figure out, if I need to do that, I need to know the data behind it. This can be used this is where data analytics come into play. Your models are nothing but to figure out, that's a question which is there, right? Improve efficiency. My data analytics that's what I will, this is a question for me to improve my efficiency. What is the current efficiency? How I improve it? Okay. So the analytical model which will come into play would be to look at this data which is there. What is the data which is there underlying? How many users are there? How many steps does it take for them to do it? What are the steps which are there, right? And how many minutes or hour they spend in building each of that, right? In a manufacturing plant, which will be it is like your streamline of parts which are built and then finally assembled to a machine which comes into play. In a RPA world, the transition comes in, how many steps it takes into complete the transaction. So how do I improve the efficiency? In the world of RPA, I can look at, maybe if it is there, my data may suggest, look, there are 1,000 bots are running, but the way it is running in the process stream, I'm putting it a high level so that I'm not getting into detail of this, because that is on doing it exactly, looking at the data and to doing a data analytics to figure out where this issue is to come up with it. I'm just highlighting how, once it's highlighted what it is, for example, if I'm running 1,000 bots, there's a 24-hour window which is there for bots to run, but not necessarily they can run the 24-hour window, right? Because transaction has to come in a particular stream and that will be a timing available and they'll run it. But within that, are those bots running to peak limit? Can the bots be do it in different time slices? Okay, but that, to resolve the problem, you need to figure out the step which is run. Can the steps be broken down to different groupings? That way bots can do it parallelly and then that can be taken. Okay, so this underlying problem which you're talking about is data analytics itself, because you're looking at the data which is there for what it need to be done to address the question of efficiency. The models which will be utilized will be different for each problems. Okay, but the theme behind that is, I need to use the data and that has to be analyzed by data analytics, right? The data scientists or data analysts to figure out what it is. Okay, they may wear a different hat, but it is the performance. This is the theme behind that. Did I answer your question, or is it hello? Hello, whoever asked the question?
Yes, sir, sir. Yes, sir.
Yeah. Did I
Actually,
answer?
yes, sir. I got it, sir.
Okay, okay.
Thank you, sir.
Thank you. So that's
Sir, there's one question in the chat box.
Sure.
What kind of algorithms used? Are they based on reinforcement learning?
Reinforcement learning is it comes to ML, okay, machine learning. Not necessarily, that's only one this thing. Okay, every I'll now model, if we talk about, will have a reinforcement in some form or other. Reinforcement can be baked into some models. That's different. Some models will be done manually. That's a difference. It is applicable across all models. It's applicable across even your data analytics when you're trying to do it as well, because that goes into, as I said, your golden data set is not stagnant or stays same for throughout the period for your ML models as well as for data analytics. The reason being, you do a sampling at one time for a particular problem. You figure out how it works, your model works well, or your algorithms works well with the accuracy level and whatnot, you go on. But then there are errors which will also occur. Those errors, reinforcement model basically does is it requeues into that itself and then goes through that automatically. But a model which gets retrained is also a reinforcement in one way. Okay, but the retraining happens at a particular frequency that is being determined by the ML engineer or the whole data scientists who are there in this stream. How they determine it. For example, when you introduce a new machine learning model into play, your auditing will be happening for a higher percentage of transaction which comes into play. For example, it can be even as high as 20% of the data which is being processed, maybe audited. When I meant unaudited, it is not just your what is being thrown into the error queue comes to manual processing, but the one which is being processed by the model itself. There's an echo there. Can you mute yourself, please? Thank you. So what happens is when any transactions is processed through the machine learning model, or even now data analytics for that matter, auditing will basically look at the accuracy of that process to identify how it is. The reason behind this, again, for retraining the model, because as we go through this, whether the model works well or not. Yeah, you do a huge amount of testing, all those kind of things, put this in production, but then in reality, in real world, you need to understand that there's also always a time constraint, right? You can't do testing forever. So there will be certain risk tolerance. You will accept that and put this into play in production. And that's why that auditing percentage will be higher to start with, because both business need to have confidence on what we are getting and what we are not getting, right? So the business decision is to have a higher percentage audited to get a confidence level. So that also in one way helps you to determine how good your good data set is, a golden data set is. So that is where your crux of the matter, right? So if the model is
excuse me.
Yeah.
It is not changing.
What do you mean?
After 5 minutes, it is same PPT is coming.
You mean to say PPT is not changing? Yeah, your use case is sitting. Okay. So use case is still there. I'm just answering your question. I thought you were talking about model is not changing, data is not changing. Which screen are you seeing anyway? Sorry. Are you seeing the use case screen?
Use case 1.
Yeah. I have not changed the screen. Since I'm answering the question, it is not related to the use case. Not necessarily, so I haven't changed it. Okay. Now, back to that question, right? So what I meant is reinforcement. Some models have it, integrated in them. They work as it is. In other cases, reinforcement happens, but it happens for the based on the data which comes in changes. Because the transaction errors have occurred, then that auditing captures it. You look at why it is happening. The error percentage is higher. Then there's that means you need to reinforce or change your golden data set to retrain the model again. So this is where the reinforcement happens. This is a manual work of reinforcement. In some models, that is integrate into the model itself, which does it auto reinforcement. Small answer, big answer. Hope it answered your question. If not, please, whoever asked the question, please say yes or no, or maybe I can add more detail to that.
Yes, sir.
Hello?
Yes, sir. Yes,
Yeah.
sir.
She said, thank you, sir.
Okay, okay. Now, I just want to be clear. This is very, what do you call? I don't know whether people are understanding it or not, or are we, you know, is.
We understand, sir.
Yes, sir.
Okay.
Actually, it's clear, sir. Please continue.
Okay, great. Thank you. So that being said, I think this use case itself, we talked about a little bit on how it is. So I'll move on to the next one. I think we talked about this itself in so many other ways. So see, other use case I'm going to talk about is on claim processing, which is in healthcare claim processing actually. Fraud is a huge, you know, problem in US healthcare. Okay, it's similar for even banking as well. Banking is anti-money laundering. Money laundering is a huge issue, and there are a lot of efforts that have been put in place to detect it. Similarly, here as well, there are you know, existing models which is sitting there for already an automated process in IT. Okay, but that being said, there are so many process of claims happen by manually as well. A huge amount of process, claim process happens manually. When I say millions and millions, it's not small numbers. You would wonder, hey, look, you're talking about automation, why so many claims has been coming to manual queue? But there are various reasons, which I talked about earlier as well, on constraints of business, different states and you know, federal rules which changes, and you know, even within state also you may have different rules which comes into play at a different point of time. Okay, that being said, no, you know, the different use cases within that, or problem statements which I'm talking about here, is where are for your data analytics, and where RPA can, you know, bring the data which is required for the to do the analytics, which is your claim patterns for the same disease across different patients. I don't know whether you're getting it or not. For example, same disease, there are claims coming from multiple patients, but the claim patterns for that is different. See, that is the one way of identifying fraud. What it means, if for example you have a liver disease which comes into, you can claim only in a there's a predetermined you know, group of claims which you can make within that. When I mean main group of claims, please understand, claim and medical billing in coding is a very complex subject, because the way the industry is defined is also complex. You have within liver disease, it may have multiple you know, subheadings, and depends on the parameters of your conditions and your insurance claim. You can only claim so much of it. Okay, and with that also you can only claim certain procedures for that. So though they have all these groupings, the claim can have a different set of, you know, claim parameters they may do. For example, I may claim for hospitalization for 3 days. I may claim for hospitalization for 5 days. I may claim for, you know, procedure number you know, 1, 2, 3s, or you know, 5, 6, 7, whichever, right? So when they analyze a fraud or bogus claim, or claim you know, overloading, they look at this pattern to see you know, is there a fraud happening in the claim or not. Okay, so that's why the pattern matching comes into. For same disease, different patients, are they claiming way differently? Then this is where it goes into your analytics you know, realm, where this data of what am I claiming for the same disease, how it is, you know, mapping. Since this data will be captured when RPA processes it, right? It has certain guideline to how to do it today. It'll go, but then when this model is applied, it can also do a prescriptive, analytics for, look, this looks like a false claim or claim which is exceeding its, limit. That can go through a model, and then that prescriptive, input can come for RPA itself to deal it differently. It can be done for manually also, but it can be, once the data is fed into the model, then this also goes into the model for that prescriptive analytics. So that's where, the data analytics comes into play there. The other use case, did you guys understand this use case which I'm talking about? I know I'm talking about multiple use cases within one. There are many which are there like that. Did you understand this particular use case you talked about?
Sir, actually I understand, but the problem is the first one you have told that analyzing claim patterns for the same disease across different patients.
Correct.
Okay, in that also there are possibility of claiming different amount because of the side effect and other things also possible. Similarly, can we explain with some example how they can analyze this category and identify the fraud claim?
Okay. Yeah. Say, as I said, right. For example, these are predetermined, or each healthcare provider limits what it can be claimed. Okay. So that is there as a guideline. For example, as I said, you said subsequently some other diseases there, or a degree of disease, all those things. Yes, but that's a code for them. Okay. So if I have this, then I will use only this code. So that's how they try to limit this.
Oh.
But it's only a guideline, right? But
yes.
that's only, as I said, that's only a guideline to have it. I can always go and claim something as, look, as I said, my degree of disease is higher. I have, this is what I want to claim.
Yes.
But then each disease also has a particular parameters. See,
Yes.
how they look at it is this applicable? See, that if I have the same, demography for this kind of disease, for this type of parameters coming in for claims itself, for claims are coming for this demography, for this age group, for this disease, similar pattern of claims are happening. And when I mean claim categories, okay, which is non-prescribed, which comes in. At times the provider may agree and pay that. Okay, then that's what they want to analyze it, because this is where the fraud will come into picture. Okay.
Yes, sir. Yes, sir. Yes, sir.
So that is where that becomes a problem, because they want to limit the amount they want to pay. At the same time, they will not go out and deny for everything which comes in, because there's a variation which comes in. But if the variations are common across demography, age, sex, something like that, then they may agree to go ahead and pay that, and then they go analyze to upgrade their system. Okay, or in the sense include those codes in the system. Okay, if not, if that standalone, for example, few cases coming in, some cases how it will happen is, this may come in from a particular doctor or a particular hospital or a particular clinic in a particular state, right? Then that's a red flag. That is where they'll go analyze to figure out why is it coming from this particular, claims are coming differently for this place. Is it truly there or not? Because that's where the fraud comes into play. Make sense?
Okay.
No, does it make sense, or am I convinced you or no?
Convinced, sir. Okay, sir.
Okay. No, I can't explain in medical terms, because I can only go so much into medical.
Yes, sir. Yes, sir. I understand.
detail.
I understand. I understand.
Sorry about that. Okay.
Okay.
The next one which I'm going to talk about is on upcoding. So again, as I said, healthcare in US is very structured in so many ways. So when I say coding is, when you claim something, the hospitals need to use something called medical coding or billing coding terminology. When for example, your liver disease there, in a claim, you can have, they will have, these are the medical codes you can use for your claim. So they will put that medical codes. It's nothing but, could be a 5-digit M02CC51, whatever, something like that. Right? There's a medical code which is there, which will translate to a particular claim. For example, liver disease, I did a liver bypass which I've done, biopsy I've done, right? That could be one medical code. Okay. So what I mean upcoding is, see, this is typically they do it to when a claim happens, but when what they do is within this, as I said earlier, you can't claim which will do differently is we can also add a additional process which is not there earlier for claim, but in direct upcoding is each of these also have multiple layers of codes. What I mean is MC01 may pay you $10, okay, whereas MC02 will pay you $20 for the same process depending on the degree of what is paid. Okay, in each of the claims they have a limit which they can have it, or for the medical billing you'll have a limit. Sometimes what these guys will do when they submit the claim is they will do, instead of MC01 they'll do MC02, right? Typically a processing which happens when they're processing a claim, they will run through this to see whether it is applicable for them or not, and then they'll degrade the code and then they'll pay. And if it is lower and not acceptable, whoever is claiming, they will appeal for that, and then that time they'll analyze it and then pay them. That's a typical process. Okay, because human error can happen, that happens. But sometimes this also happens as a pattern, which are talking about that for a particular disease, that there could be a new disease or new process which has been introduced. So the medical billing is not necessarily completed there, or the structure is not predefined very well. It is yet to be defined, or it has been evolving. Then upcoding becomes a bigger problem there, because they'll try and use the situation to claim more. You need to understand, typically what happens is a patient get admitted to the hospital claims it, and the hospital will get the benefit, or doctor from a clinic gets it and then they'll gain it. It is not goes to the patient. Patient actually pays only the copay, right? What is minimum they need to pay, and then as you know how in insurance claims happens, right? So it's not coming, I pay out of my pocket and then claim is not going to happen. The hospitals does it. So upcoding benefits hospital because they can get more revenue. So they will, this is where the fraud comes into play, and that is where upcoding also happens. Okay, so that is the other part of it, which is you're unnecessarily claiming for the diagnosis, their service is not needed. If you claim it, that becomes upcoding. Okay, did you guys understand this?
Yes, sir. Yes, sir.
Okay. Okay. So the other use case is duplicate and phantom billing, which is for the same patient, they may do a duplicate billing. It's actually quite common. Duplicate billing is a percentage which happens, especially in US, quite common. And phantom billing is a patient is not even existing. Okay, they'll try to bill them, or put that in the system, and then it'll come through. This phantom billing is duplicate billing is maybe relatively straightforward to figure out, and then figuring out a pattern for that, and then see how it happened. What I mean here to data analytics is, see, this data will go into analytical model to figure out which providers or hospitals actually are misusing something like this. Is it happened in the past? Is it happening in which part of the state? Or if it is a national level provider, it's happened in different places. How do you address it? Because it's a ongoing process. It happens all over the world, all over the states, and it keep happening. So they need to figure out how to reduce it, not eradicate totally, because it never happens with humans involved. So they will try to figure out how to do what can be done to reduce it, or what is the fee, what do you call penalties they can impose on them, that kind of thing, right? So that is where this also comes into play. All right.
Actually, in the third category, the detecting upcoding and discover duplicates. If the data analytics perform very good, means really it is a great task, sir. Because
Absolutely.
the medical persons can give report. So based on the report only, everything can be claimed or disclaimed. But
Yep.
with the information given by the doctor, if the data analytics find the fraud, means it is really great.
They do, actually, as I said, right? Look at the data which is there. The fraud in US is around 80 billion annually. 80 billion. It's not small amount, right?
Yes,
it's a huge amount of money. So that's why all this comes into play, because you need to have right data filled into the right models to figure out what is happening. Today they do to a certain level. And the duplicate billing can be figured out, fairly okay, but not necessarily everything. And there's so much which, see, with what they are already figuring out, you're looking at 80 billion. Okay, with analytics in play, it can reduce phenomenally, and some of them are already doing it. Last I knew, there are a few projects which are going on these areas, which they have integrated analytics with RPA to reduce some of these. Okay, one project we have already completed. I don't want to quote the who are the companies. There are 2 million in loss was they're able to do it in 2 quarters for one of them in a project. Okay, so that's it's not no small amount. 2 million is 4 million annually, and look at how much they can do it in yearly terms, right? This is on a specific area only. This was done only for upcoding. It was not so. Subsequently, they're looking at other projects actually for building duplicate building as well. But then one area, upcoding, was really complex. They have done that, so that is where they gained the 2 million in the 2 quarters actually. I don't know what is the current record is, but when we were executing that, that's what I know about. I can't share the case study with you guys because it's very client confidential. So unfortunately, that's why I'm not going into detail of which client and other details there. All right. So this is just before the final slide. If you don't have any other question, again here, clinical use cases. I'm all talking about healthcare because in the RPA world, I was heading healthcare. I can relatedly talk about banking as well, but healthcare is what I was doing it recently, so that's why I have more healthcare use cases. So there are disease outcomes you can detect using or predict it, which actually the modelings are already there. If you want to know, right? Predicting disease outcomes are already there in quite a few places. Because that's one model they use it for even their claim or your insurance fee, right? How much you can charge. That is something which is they use this model, actually predicting disease outcomes, which is already used for your insurance fee structure. So what can be claimed, how much is the limit? Because health, if you're as a payer, when I say payer, insurance companies, they don't want to pay a lot of money, right? They want to limit the outflow. They also want to run an organization profitably. So what they'll do is it's like when you take insurance, how much of premium you want to pay, right? So if certain diseases need to be included, you have a higher premium. So that is determined by this disease outcomes as well. What it does is high level, a particular demography, a particular age group, if they have certain habits, they predict certain type of diseases for them. Okay, if you're a smoker, how they talk about cancer, this is pretty straight line they've drawn already, right? But this is even more, right? It depends on your type of food habits they have, in which part of area they live in, what ethnicity they may have or the age group, based on that, determining in this particular group will have these kind of diseases which will come. So higher possibilities been predicted. These are models which are really interesting, right? So that again goes back to the type of claims which has come in the past, right? And then they marry this data with other data which is environmentally available for that particular demography, and they come up with this predictions. Okay, and the next one is predicting treatment plans, right? Which is what comes into play for your earlier one, which I'm talking about, even for fraud prevention. What they try to do is a particular disease need to have these kind of treatment plan, even with varying degrees of courses. As is, who were asked that earlier, disease may have different severity or different symptoms which comes into, but even with that, the models typically depicts type of treatment plans which you need to have for these. Obviously, these will have a limitation. It's not like exhaustive, it won't be correct, but it gives you an outline what can be followed. Reason is simple. As a payer, when I mean payer, insurance companies, I always want to protect my interest of how much I can pay, right? I don't know whether you guys all would have heard about it. Any natural calamity happens, insurance companies won't pay, beyond a certain limit, or somebody will not even pay unless you specifically insure for that. Okay, so in this case, when a disease which comes in, it have different degrees and different type of variations are there, then they want to limit the amount of money they want to pay, so they will have a treatment plan also which will structure in such a way. So the one thing which is good from a patient point of view is they know at least what they're getting into. Look, this insurance will allow me only this much. That means something I need to pay out of my pocket. The doctors or the hospitals whether they can use experimental treatment or not. Some insurance plans will not allow it, some will allow it. So that means they can go for that. Obviously, that's good and bad, but that's how businesses typically work, right? So that's where it is. So now the other part is predicting benefits of certain drugs. See, all you can see, these are predicting. This is a predictive, analytics which comes into play, right? So which is whether you look at in ML or data analytics, both are in a similar pattern. Prescription auditing. What do you mean by that is, who were asked the question, doctors has to give this, right? Doctor has to give the prescription, but the prescriptions is the other bigger fraud area as well. For example, they can pad the prescription. This typically will happen in quite a few hospital bills. They can pad it because it's very difficult to figure out what has been added, which is unnecessarily or not. It could be done by some doctors to misuse some drugs, right? It could be somebody stealing a prescription and doing it. So that prescription auditing also comes into play, where they will figure out how to identify is anything out of play or not. Okay, then tracking patient prescription refills, identify patient risk and substance abuse, which I talked about substance abuse earlier as well. Again, that also comes into specific details of how I identify problems there, which is patient risk and substance abuse is interesting topic there, because the type of risk is patient risk is something like this. Whether this patient will go into remission of the same disease or not can be determined by the data which is being fed about the patient. So that's a very interesting topic. That's very useful for both provider and payer. When I mean provider and payer is insurance company, provider is your hospital or doctors, just to clarify, right? So they need to understand whether the patients will go into remission or they will progress into certain disease, because they have this does mean that they will get into that, will help them to do a preventive steps earlier on. You would have also, if you have medical insurance, even in India, you will see that above certain age, your healthcare or health insurance companies will ask you to do once in 3 years annual checkup or yearly annual checkup, or a particular, they will have a type of checkup they need to do within that will be determined. The reasoning behind that is to do a prevention, which is that patients' risks are analyzed, and that's how they tailor this test as a prevention methodology. Okay. So any questions on this?
No,
I know.
sir. No, sir.
Hey,
No,
sorry,
sir.
sorry, this is all very domain specific. I don't have any other option, because otherwise it become I'll need to be a professor to talk about data analytics. I don't want to do that. So hopefully you guys got a glimpse of how it is. But if you understand the domain, it becomes a lot easier. But
Yes, sir.
otherwise,
Understand, sir. Understand.
it may be a little difficult. Otherwise, sorry.
No problem. We understand, sir.
Okay, great. So any other question from anybody else? I come to a conclusion. I'll maybe re-emphasize one thing, right? So that you guys, if you have any question, you can ask after that. What I wanted to talk about or talked about was data being it's truly that's a currency. Digital currency is data in all forms, in all, this permeates everywhere. If you have not already understood that, leave alone what use cases I talked about, which is there for everything which you guys use. There are examples of Google, jokes would have been there. Maybe I'll tell you one which is there, right? There's this guy driving in his car, and Google automatically does it, Alexa, or right? It gives a say that, congratulations, sir, you're going to become a parent. His wife is sitting with him in the car, and she's looking at him. I'm not pregnant. What happened? Actually, he ordered pregnancy test for his girlfriend. She tested it, and it became positive. It knows, and Google knows it. Google actually played it in. So data is been collected when you order. It's been tested. Results are there. They're actually passing the information back to you. This is given as a joke, okay? But look at how whatever data whatever you're using, that information has been captured in many forms and throughout all layers, and how it comes back to you itself, right? It's just a joking example, but there are so many other such scenarios already there of collecting data, right? The reason why they collect data is very important. That being said, when you come to business, outcome, how the data which underlying there can help in driving a better business. That's where we talked about today. All streams which are there in a business, it need to be looked at interoperability or interlinked. Okay, that's the best way to gain the maximum benefit to drive business forward with efficiency. If it is looked in silos, you'll have a lot of challenges. Business can't run that well, it won't thrive that well. Because you run only RPA in a silo, data analytics which runs in silo, then the amount of money and time you spend on data analytics will be far higher than leveraging tools which are already existing, like your RPA, right? And the other part is you're also integrating ML models into that tools itself, right? When RPA processing happening. I talked about your prescriptive predictive models loop back into RPA or human queue as well. When they process something, then it will pop in to tell, look, there is something risky there, which you need to take a different action, or you put in a different queue so that somebody else can take a look at it. That kind of predictive or prescriptive methodology method can also be done using this. So that they already do it. Examples of chatbots. They already do some of these things as prescriptive and predictive models there. But anyway, I'm digressing a little bit there, right? I'll stop at that, and if anybody has any questions.
Yeah, there's a question in the chat box, sir.
Sure.
Yeah, regarding chatbot, how the performance is evaluated, how the gold standard is fixed for chatbots.
See, chatbots are typically not, you don't have a ML models for chatbots typically, okay? Most of the chatbot, if you look at it, have a predetermined tree structures of question and answer will be there, okay? Typically, it doesn't have, ML model. There are ML models are worked upon on that as well, which does answer, questions on the go, but there are not very many at the play. Very few are there because there are some. It is not yet completely error less at this point in time, because as customer interacting, they can become pretty bad suddenly. So they have not full-fledged went into that and quite often. Okay, so
maybe we can say it is a rule-based system, right?
it is rule-based. That's why it's rule-based at this point. That's why I said tree section already. It's rule-based at this point, but not your ML models are not necessarily used that much here. There are some which are using it, but they're limited. Can you repeat the question again? I don't know whether I answered completely.
How the performance of chatbot is evaluated, how the gold standard is fixed for chatbots.
Okay, so gold standard, she said golden data set. I don't know, gold standard is applicable here, but golden data set, but not necessarily applicable in that way. As I said, because it's so evolving, that's why they don't use ML that much, but they use artificial intelligence for this chatbot from our response perspective, but mostly rule-based. But then efficiency part is on how they will determine is how many users are happy with chatbot answer. In the end of chatbot, if you look at it, are you happy with this, resolved it or not? Your uptick load, thumbs up will be there, right? That's a typical data which they use for figuring out efficiency of a chatbot. That tell you how efficient it is, means how many questions to answer, or how useful was it to that or not, so that they can figure out additional rule set or redirect to human queue. That's a typical process steps in a chatbot and how efficiency determined.
Sir, I have a question.
Yeah, go ahead.
Yeah. Regarding this process automation, to what percentage can we automate a processor?
Okay, theoretically 100%.
Yeah.
Okay.
Real time.
Yeah. Theoretically 100%. Reason being, as I said, there are two reasons. One, my input data is digitized, that everything can be automated. Okay, that also I'm saying theoretically. The reason being, for example, I'll give you an example where it is very difficult to automate in that aspect as well. I'll have user comments for a particular processing, right? The user comments can have nested comments. I hope you get what I'm saying, right? Example, day one, I raised a query for a particular claim. I need to have this. I'm saying disputing this claim. Okay, and then you analyst. I'm the analyst. I'm responded back saying that, hey, look, this is the reason, which is why it's been not paid. As a user, you are responding again with another query and then explanation to that. I'm not the analyst anymore. Another analyst comes into play and they respond. This nested response back and forth is sitting there as a history. Okay, it can run up to 80, 100, whatever, but it can vary, unlimited, right? Depends on how much it can go. A bot need to go through these history to understand a question which is asked first, whether it is modified anywhere in between, and what was the resolution to that before it can go and process the request. You understand what I'm saying? For example, say I am claiming for a biopsy. Okay, and I've claimed $500. In the course of communication between multiple analysts, my doctors, inputs and whatnot, finally, in between I've agreed for a 300 claim, and you have said 250 is okay. And then somewhere I'm saying 300 is okay for me, but 250 is what you'll give. It is fine. You guys, I've already paid, my copay of, $500. So this is a problem. Can you help me? So somewhere somebody else as a supervisor agreed, saying that, okay, let's pay $100 bonus for this guy. I need to do this. So this is I'm giving you a lay of how many transactions just happened, right? Or communication just happened. So what have we finally decided? There's $100. We are saying, okay, we'll pay in addition, but it is not $500. Is it 250, which is agreed, or 300? You need to figure out this among the multiple conversations which has happened. So that's where the complexity which comes into. That becomes a little difficult from a what perspective of analyzing it. When we're talking about this, it's easier for us to figure out the conversation to pinpoint it. I'm just giving a very simple nested comments that becomes easier. Even the data is digitized. There, the amount of complexity of automating is far higher, then those may not go into play. Otherwise, automating is fairly possible. So theoretically, 100%.
With respect to decision making, it becomes complex.
Yes. It is, even otherwise it's complex for any IT system. If you look at it, if you have these many human conversation which happens, communication, figuring out is vastly difficult. Your AI comes into play here actually, because they need to figure out, filter it. It may not be direct AI, but if you look at your neural networks and other things, this is how it happens, like nested comments, and then how it has been resolved. So that how it it will come into play. Okay.
Yeah. This Dr. Pankaj Kumar has raised his hand. Do you have any queries, sir?
Yes, madam. Thank you, madam. Myself, Dr. Pankaj Kumar Singh from IIT BHU.
Hi, Pankaj.
Hello. Your presentation was quite informative.
Thank you.
My question is that, do you have applied the data analytics in solving any problem experimentally? Can you share that thing, how you have solved your problem?
Pankaj, this is what I talked about on the upcoding, and in claims fraud we have actually applied it, but I can't share the details beyond what I've shared in that presentation because it's very client sensitive. So I can't tell the client name, but I can tell you the use case, right? This is what these two places we have used it actually, which I have been part of.
No, I want to know how you have solved. If any basic problem you have given, how you are going to solve by the data analytics?
So what I meant is for claims fraud, right? We have reduced the claims fraud to the tune of $2 million in 2 quarters. Okay, for a particular payer. That is the problem statement. How it was applied and solved is on the, see, I have only managed the project from an RPA perspective. Okay, the data fed into data analytics team, and they are the one who worked on the problem to solve it. What models they use, I don't have it, and I will not be sharing it this anyway because it's client specific. I can't share the detail either. So I have a case study. I can't share that here.
You know how to solve the problem?
I don't know myself. There's a data analytics team which are there. They did work on it. I have not worked on it myself.
You are not aware about the what programming
algorithms. I know high level, but I can't share them with you. That's what I'm trying to tell you.
Maybe Mr. Pankaj Kumar wants to know the method names and so on.
I do not have all the details, Pankaj. Sorry.
Okay.
I manage only the RPA part of it. We worked with them to feed the data.
Mrs. Chandra?
Yes, madam. Thank you. Good evening, sir. The session was very informative. I hope I'm audible. Yeah.
Yes.
And I just wanted to know, yeah, you said you cannot share the methods. Just out of curiosity, I'm asking, in what way this RPA is actually, it is different from traditional data analysis, because all our data analysis, prescriptive or, predictive or descriptive, we put lot of intelligence capability into that. That is the role of ML and AI, deep learning, all those things it is taking care. Especially with respect to RPA, can you just highlight some methods or the model which is frequently used in generic? You need not actually tell the client perspective and all. In generic, which are all the methods are actually, it is performing good
Yeah,
with
Chandra.
respect to, yes, sir.
Yeah, I got your question, but RPA is not necessarily use any models. Okay, RPA is
Okay.
only a now your data, your robotic process automation only. It's only automation, right?
Only for
But
which automations or data loading point of view you're talking about? Because I
no,
just wanted to know the difference between RPA involved in data analytics
yes.
or without
So
using the RPA.
yeah, what I meant is RPA is a tool to capture data which you require for data analytics.
Okay.
Say
Okay.
you data analytics, for data analytics models to work, you need to have qualified, classified data, cleansed data. Okay, that is you once you collect even data for any analytical model, you have to do all these processing steps to figure out what data required, and I need to collect the data. Typically, the data is collected manually, or you need to figure out how it is.
So the main role of RPA is from the data collection point of view, sir?
Data collection, data aggregation, right? The data
Okay.
collection aggregation is where RPA comes into play.
Yeah,
Okay,
actually,
fine.
I think Mrs. Chandra's question, each of the participant here will have it in mind. The thing is, like, whenever we hear a word called robotics, whatever follows it, like we think about embedded systems.
Yeah. So it is
So
it is
that,
embedded. Actually, it is embedded only if you look at that, right? It is embedded system only because see your IT systems are already there. What happens is this is nothing but RPA tools will mimic a user, but in a GUI virtually. That virtual machines are there, which is what it is RPA is. So it's mimicking human actions, but in a virtual GUI environment. So that's what
Can
RPA
you
is.
just highlight some of the points which is actually mainly use it to mimic the humans for in the data collection process? That's what we wanted, because I could
Right.
not differentiate the RPA involved in data collection, because we use a lot of automated techniques for the data collection, right, sir?
Correct.
Since you involved with many clients, if you can just tell
Yeah,
in
sure.
generic, not disclosing some confidential information. Yeah.
Not
Thank you.
necessarily. See when as you see that RPA, processes end-to-end claim, right? I will take a claim for example. So all pertinent claim-related data passes through the RPA tool, right? And different type of claims processes through, and the actions taken to process the claim is processed through that. So this is an example, right? So if you want to identify fraud in a claim, you need to figure out the type of where it came from, what data which is required, right? You need to have aggregated data of age, patient information, disease information, right? Now, what type of claims they have done. So all of this information in a standard format you need to have, so that your model can process it. That because when you apply any tool to collect it, either you need to collect it from what is there, because there are certain decisions also happen when I process a claim, right? So there's variation which comes into play. So that also will be captured in tool, because instead of human collecting it, tools collects it. RPA collects it at that time, and so that process data will be aggregated and fed into your data analytics model. Make sense?
Thank you, sir. Thank you. Yeah.
Sure.
any other
All right.
questions from the audience participants?
Mr. Pankaj, I'm very sorry I can't tell you the models. I'll see whether I can get that model detail, if I can. Then I'll pass it on to Dr. Lavanya, and then she can pass it on to you.
Yes, I'll do it.
Any other question, guys? All right, if not,
Yeah.
I'll,
So we shall wind up, sir.
all right.
Yeah,
Thank you,
couple
sir. Thank you. Thank you.
Thank you very much.
A couple of minutes for a formal vote of thanks, sir.
Sure.
I deem it a great honor to propose the vote of thanks to all who have helped us in making this international congress on industry perspectives of data analytics such a resounding success. I thank our resource person, Mr. B. Saravanan sir, for his valuable time and knowledge sharing with a real-time use cases. It was really a useful session, sir. Thank you very much. Let
Thank
us
you for-
meet tomorrow at 3 p.m. with another interactive session on the topic Trends in Advanced Analytics, Digital Twins in Healthcare by Mr. V. Subramanian, Senior Technology Manager, Honeywell International Incorporated, Atlanta, GA, USA. Thank you all.
Yeah, thank you, sir. Thank you, Mr. Saravanan, for your valuable time and patient question and answer session also.
Oh, it's my pleasure. Thank you very much.
Thank you. Thank you all.
Thank you very much,
everybody.
Mr. Saravanan, for having brought the wonderful session with real-time use cases. I hope this is eye opener for all the participants. Thank you.
Thank you.
And special thank you for Dr. Kadirvalavan Kumar
Why?
Thank
for honoring
you for
us.
active participation, sir, and
Being interactive, I guess.
all
Yes.
the participants have been appreciated.
Yes.
Thank you. ma'am.
Now,
Thank you.
one feedback from me is it will be good if it will be more interactive, actually. More participants ask questions in between as well, make it a lot more interesting.
Yes.
Yes, sir. Yes,
Anyway,
sir.
thank you very much.
Thank you, sir.
Have a nice day, everybody.
Thank you.
Yes,
Bye.
sir. Thank you, sir. Wish you the same.
Thank you, ma'am. Let us meet again tomorrow.
Tomorrow at 3 o'clock. Yes.
Yes, ma'am. Thank you, ma'am.
Thank you, sir. Thank you, participants. So tomorrow again, we are going to have a blast on knowledge sharing on trends in advanced analytics, digital twins in healthcare. So be available at 3 o'clock and we are starting sharp at 3. Thank you all.